Did you just find out right now, or did you? Oh, okay. Yeah, we're on. I think you're good though. You have a lot of information and you're smart behind like by your head.
Good morning, everybody. Hi, we're going to get started in 2 minutes because it's already just after 1, so last chance for snacks and or washroom breaks. Okay. All right. Okay, everybody. If you could take your seats, we're going to get started. Yeah. Okay. All right. Well, good morning, everybody. Quay, bonjour. Thank you so much for coming. My name's Allison Eustis. I'm the Executive Director for the Nashwaak Watershed Association, and I'll be your MC for today. I'd like to start off with a land acknowledgement, that the land that we gather on today is the traditional unceded territory for the Wolastoqey people who have lived in and stewarded these lands for over 10,000 years. The territory is covered by the Treaties of Peace and Friendship, which Wolastoqey, Mi'kmaq, and Passamaquoddy peoples first signed with the British Crown in 1725. The treaties did not deal with surrender of lands and resources, but in fact recognized Mi'kmaq and Wolastoqey title and established the rules to what was to be an ongoing relationship between nations. In terms of achieving successful and sustainable conservation and restoration goals, it is imperative that we leverage the values of both Indigenous and Western knowledge systems using a two-eyed seeing approach. So thank you all for taking your time out of a very busy year-end season for us all to come to this great event today. Especially, I want to highlight Tanya Germain, our Restoration Program Coordinator, for putting all this together. So thank you, Tanya, right off the bat. And all other Nashwaak staff are in-house today, and they've also done a tremendous amount of work, so thank you to them as well. A couple housekeeping items. First, washrooms. Men is in this back corner, women's in the front. Fire exits as well are designated under these two doors. A muster station is out front just in case any alarms do go off. We do have active translation today as well, so if you have a headset and you need translation, please see our sound guys in the corner. We do have a photo release form. If you miss signing it, we'll just get you to do it at some point during the break. And if you don't want to get your picture taken, that's fine too. Snacks are in the back, provided by Jenna's Nut Free Dessertery, and if you are gluten-free, please come see me as we have stuff set aside specifically for you in the back kitchen. We also have some merch available in the back and our information table as well. And at the last bit, please return your lanyards at the end of the day because we will reuse them. For presenters, Kate Turner, who is in the back here, will be keeping time. So just keep an eye for her. She's probably be in this back corner. Keep your yellow tickets as we will be doing a raffle draw throughout the day, maybe at the break, and giving away some Nashwaak swag. And then last bit, please check that your phones are on silent or vibrate just so we don't have any major interruptions during the presentations. Okay, that's all for me for now. Let's get going. Forgot that I do Juan's intro. So up first is Juan Sanchez and then Dario Wisniewska as well. So Juan is our species at risk technician who organized our bank swallow monitoring program this year. His surveys will continue this year and will be helping with various projects as species at risk are pretty much integrated into all of our different projects at the Nashwaak. So thanks for presenting, Juan.
Good morning, everybody. Just one second. Hello, hello. Good. So today I'm going to talk about bank swallow and erosion, how erosion creates vital nesting areas. So to lay the groundwork, I would like to start by giving some definitions. So erosion is a geological process in which materials are worn away and transported by natural forces such as wind, ice, and water. And in the case of rivers, the natural course of water wears the land away and transfers it to further locations as sediment. As a result of the constant erosion activity, distinct landscape features can emerge. And one of these are riverbanks. Riverbanks are land bordering rivers, are the land bordering the river that, due to erosion, they have a higher slope compared to adjacent land. And most Canadian rivers, as the Nashwaak, they have an abundant quantity of riverbanks, given the glacial origin of these banks. Despite being a natural process, bank erosion has become an increasing concern as a result of the human influence on factors controlling the erosion rate. Some of these factors include the removal of vegetation. As you can see in this picture, this is a bank that has an abandoned hayfield on the top and where big chunks of soil have just eroded recently. And this had caused that human influenced riverbanks had a higher erosion compared to natural banks. And there is also another factors that can influence erosion, like for example, increasing flooding events due to climate change, that will cause some impacts. So increased erosion and subsequent land removal have significant economic and environmental impacts. And these have led to the promotion and the adoption of erosion control strategies. Well, despite being a natural process, erosion is being labeled as an inherently negative phenomena. However, riverbanks, as a transition zone between the water and the land, are very important habitats for multiple species. And this includes the bank swallow. So the bank swallow is a small migratory bird that is easily recognized by its brown upper parts, white underparts, and a brown bar across the chest. The bank swallow is a colonial bird that feeds by hunting insects mid-air. And as the name indicates, the bank swallow have a special relationship with banks. It uses banks and cliffs as nesting sites, where they excavate burrows to attract females, lay their eggs, and they raise their young. So the bank swallow, as many other aerial insectivores, have faced considerable population declines, which up to 98% decrease over the last 40 years. The causes of these declines are not very clear, but may include habitat loss, exposure to pesticides, climate change, and changes in insect availability. So regarding habitat loss, lots of research had been done to understand their preferences of nesting habitats. And from these studies, there is one thing certain. The bank swallow can be quite selective when choosing its summer stay. So when looking for a nice summer stay, the bank swallow usually check for multiple attributes, including, well, I have divided these attributes by three groups: structure, soil qualities, and surrounding habitat. So the bank swallow tend to prefer banks that have a height slope over 70 degrees, a height about 1 meter, and a length above 60 meters. All of these attributes to reduce the chances to be predated, and also to have suitable banks that they can excavate. We can further divide this characterization of the banks by dividing the banks in two different areas. The upper part, that is usually called the face of the bank, where the bank swallows will make their burrows, and the talus, where all the sediment is deposited. And well, these have some important attributes for the bank swallow preference of their banks as well. The face, they need an exposed area of above 0.5 square meters. And they also need a high talus to avoid predators to have easy access to their nest. There are also some factors related to the soil that influences their capacity to excavate it, including the size of the particles in the soil, the pH, and the conductivity. And also, they have some preference about what habitats are surrounding those banks. They like to be near running water, also to reduce the predation chances. They prefer to be close to grasslands, because these are very important locations for their food. And they like to be near wetlands, where they tend to roost. So while they will raise their young within the burrows, every night they will go to different locations at wetlands to roost at night. All right. So as you can see, erosion is a factor that is influencing most of these aspects. So this makes erosion fundamental for the availability of bank swallows nesting habitat. But more than that, erosion is also very important for the quality of the bank swallow nesting habitat. While every year erosion will guarantee that the bank has a clear face without vegetation, so it has access to their nest, and it also reduces the chances of banks using old nests that can have some parasites on them. However, we cannot forget that erosion still has very important impacts in our communities, for our community safety, and also for other species like the Atlantic salmon. So when we are considering strategies to reduce erosion rates, these have different influence on the bank swallow. So for example, bank bouldering and bank stabilization, they usually tend to destroy completely the viability of these habitats. while revegetation and reforestation, they can have both positive and negative effects on the selection of banks as nesting habitats. So this leads us back to the question that we are going to talk about today. How much erosion is enough? We, as environmental stewards, we have to take in account both sides of the equation, where erosion have negative effects that are of concern, but also it has many positive impacts for wildlife. What I think it is important to take in account is that erosion is a dynamic process, and we have to learn how to include it in our management plans. So what I can say by now is that if erosion is not threatening infrastructure and it's not occurring at an alarming rate, let it happen. It will guarantee some disponibility of a habitat for the bank swallow. And if you have to control erosion, consider other approaches not that invasive, like revegetation, that could be cheaper and be better over time. And lastly, if any work done with a species at risk should involve ongoing monitoring and necessary maintenance of the site. I wanted to show you some of our findings on the Nashwaak River about the occurrence of bank swallows. As you can see, we did a classification exercise of all the available banks at the river. The yellow ones would be those with higher quality, and the purple ones, the ones with lowest. And these are the number of colonies that we found last year. As you can see, we have a high amount of banks compared to the amount of banks, of used banks by bank swallow. And that this brings us to many different questions, like are the bank swallows not using the banks because they are not suitable, or they haven't reached those areas yet? And these also are very related with the dynamic of erosion, and incorporating this will help us to do better management plans for the bank swallow. Thank you for listening. If you have any question, I will happy to answer them. Not yet.
We're actually going to hold our questions until after Daria presents, and then we might have time for one or two. So up next is Daria Wisniewska. She's our aquatics program coordinator responsible for the temperature monitoring, water quality, and aquatic connectivity programs across the Nashwaak, as well as our annual red survey. She also organizes the Nashwaak Smolt Wheel Volunteer Program in partnership with DFO Aquatic Science technician Mark Gautreau.
Okay, hi everyone. As Allison said, I'm Daria Wisniewska, the Aquatics Program Coordinator with Nashwaak Watershed Association. And she already mentioned what I do, so I will skip that. But today I'll be talking to you briefly about the effects of erosion on fresh water quality, which I've seen play out this past summer in our watershed, mostly through our monthly water quality monitoring. So ever since moving water, soil, and rock have been present on the earth, erosion has taken place. Water plays a large role in the displacement of earth, from raindrops dislodging soil and carrying it to different locations, to rivers and oceans carving out rock over millions of years. The higher the water velocity in a waterway, the larger the particle it can transport, and the higher the erosional power. So therefore, rivers with faster flow cause more erosion than a slower moving river with the same volume of water. Billions of tons of silt coming from erosion and runoff are transported to the ocean every year. Canada's waterways move millions of tons of sediment, which end up being deposited in lakes or the ocean. And sediment can carry pollutants that have been adsorbed while on land. And with erosion, these pollutants end up being deposited in streams, rivers, lakes, and oceans. Excess sediment itself can be problematic in fresh water to aquatic life. These effects can either be acute after something like a heavy rain event, but can become more prevalent over time as erosion events become more frequent from anthropogenic activity. Total solids are the amount of materials or particles in a water body which consists of algae, dead organic materials, and sediment. Sediment can be dissolved in water or larger particles can be suspended. Total dissolved and suspended solids increase when there's erosion in water, leading to more turbid water, which means more particles reflecting off the water. The major effects of excess sediment in water include a decrease in how much sunlight can penetrate through the water. It can harm fish, including irritating their gills, damaging the mucous membrane of their eyes, and burying then suffocating their eggs. It can cause increased water temperature by absorbing light, and it can introduce pollutants attached to eroded sediment. Erosion can affect levels of dissolved oxygen in water through multiple pathways. Dissolved oxygen is the amount of oxygen available in a water body for fish and aquatic organisms to breathe. Aquatic plants also require dissolved oxygen for respiration when there's no sunlight, like at night, and then microorganisms require it to decompose organic matter. Dissolved oxygen comes from diffusion from the atmosphere into water, as well as from photosynthesis in aquatic plants, algae, and phytoplankton. Sorry. So with increased erosion around waterways, there's increased suspended and dissolved sediment in the water, which makes it more turbid and cloudy. The decrease in sunlight penetrating through the water means that aquatic plants, algae, and phytoplankton have a reduced ability to photosynthesize, which can lead to a large decrease in dissolved oxygen levels. When a waterway has very low dissolved oxygen, it's called hypoxic, usually a level of oxygen that very few fish can live on, and then no dissolved oxygen is called anoxic. So more sediment being deposited in a waterway from large erosion events can cause it to become shallower. Sediment in water also absorbs light and heat. These two consequences of erosion can lead to an overall increase in temperature in a waterway. With increasing temperature comes a reduced capacity for dissolved oxygen. As the warmer water is, the less dissolved oxygen it can hold. Warmer water can cause physiological stress and harm to fish, which can be fatal if they're in a state of prolonged stress. Hypoxic or anoxic conditions can result from the reduced dissolved oxygen capacity, as well as other factors like harmful algal blooms being more prevalent in warm water. So nutrients like nitrogen and phosphorus are found naturally in soils and many other sources, and they're essential for the growth and survival of many living organisms. But of course, since they're found in and around soil, shorelines, urban, and agricultural areas, nutrient levels can increase in water when these places erode. When there are too many nutrients in a waterway, it's called eutrophication. Because the nutrients are so good for plant, bacteria, and algae growth, it causes an overgrowth of these organisms. Eutrophic conditions can cause anoxic conditions from all the dissolved oxygen the plants and algae consume, and harmful algal blooms can often be found in these conditions as well. Last slide. Minerals like iron, calcium, magnesium, and manganese are naturally present in rocks and soil as well. And for the most part, these are normal and safe components of rivers, but a large erosion event can cause an excess of any of these minerals, and sometimes depending on their interactions with other ions, these can be toxic to aquatic life. Heavy metals like mercury, lead, and cadmium also naturally occur in rocks and soil, but then anthropogenic sources like wastewater treatment plants and pulp and paper mills can also contribute to heavy metal levels in the environment. So when there's larger erosion events, this can cause spikes in heavy metal levels as well, and these can be toxic at low levels as well as bioaccumulate in fish. So hopefully after that we have a little better understanding of the effects of erosion on water quality. And thank you.
We're going to move right along to Tanya Germain's presentation. Tanya is our restoration program coordinator, whose responsibilities include planning tree planting events, riparian zone restoration, agricultural ecosystem work, and our natural edge program.
Okay, I'm going to make this quick to try and get us back on schedule. So, as Allison said, my name is Tanya Germain. I'm going to grab this so I can maybe move around. Just kidding. I'm the restoration coordinator for the Nashwaak Watershed Association. I'm going to share some of our current floodplain restoration work, as well as talk about our program that we have that offers landowners free services to trees and erosion mitigation methods. So currently we have two key sites, Neil's Flats, which is owned by the city of Fredericton, and Nashwaak Meadows, which is privately owned. They're both in the lower Nashwaak. We use these as key sites for, to look at methods to slow erosion, improve water quality, and support wildlife habitat. So they're great for pilot erosion models. These sites serve as learning grounds for us for adaptive approaches for erosion. And I'm using my computer. That's great. So over on this side, this is a bank at Neil's Flats. We currently had a bank restoration project on there where they re-sloped the slope at a 3:1 grade. And then we had New Maryland middle school or elementary school out to replant the slope with bur oak. And now I'm going to move on to our Natural Edge program, which is the program that we offer to landowners for free. So we use mapping tools like ArcPro to identify priority areas, environmental variables such as canopy cover, water streams, species at risk, and we use targeted outreach to contact these landholders and offer services like habitat assessments and vegetation plans, and then we provide the plants to these landholders. I keep using my computer, sorry guys. So I will stop that. This is just an example of some of the layers that we will use. And then this is an example of one of the reports that we will provide. So we reach out to the landholder and we arrange a visit, we chat, we listen, and we provide a tailored report with maps for them. Yeah, so we use targeted outreach and then informal channels to contact these landholders. Usually we plant native trees, shrubs, and this year we are looking to add in herbaceous plants for more diversity and adaptability. Also to prioritize the landholders' value. So sometimes they want to deal with erosion, but they're not willing to lose their viewscape, which is understandable. So things like herbaceous plants and shrubs can be a method around that. This is just an example of some of erosion. Up here you can see that this is considered poor quality. It's lacking vegetation, there's significant erosion and overhangs that's likely to lose quite a bit of soil the next year. This bank is considered moderate, it has some vegetation, a decent slope grade, there's not exposed sediment. This is what we would qualify as good. There's some canopy trees, a nice slope, and lots of vegetation. So not every site is ready for fieldwork upon visit. This is a pretty good example. This is some bank that has dropped off in the spring following the freshet receding, so after the floodwaters have gone down. If the water levels rise again, there is a chance that some of that loose chunks of soil could be taken away by the water, which is then going to create some bank swallow habitat depending on the slope, or it could eventually, with weather and time, grade into a nice natural slope. What we would do in a scenario like this, if there's no bank swallows present, we would go in with something called willow stakes. We use willow, red osier dogwood, and black elderberry. They're fast growing, and they'll create a root system that will hold that bank in place while we begin to plant trees farther back up on the bank. And this is just an example of what they would look like. They're hardwood stakes that we just hammer into the ground. So like, yeah, that's crazy. So like I said, some conditions aren't available. We can't plant in them right away or make any action that field season. So after our site visit, this is an example of a steep sandy bank. We visited this site in June, which is already too late to plant into the year. This sand isn't going to hold any water. It's not going to retain any water for any roots, but each week when we went, they were losing sand rapidly with every rainfall or heavy wind event. So what we did is we went in and used a geotextile coir matting. It's completely biodegradable, and we put some of those willow stakes through the matting. As expected, they didn't root because it was very, very dry and sandy. But we are planning to go back this year, earlier in the year, actually April, and that's when these plants can thrive in the soil. But in the meantime, we prevented the sediment loss from June until this April when we're able to get back in. Another example of an adaptive strategy for later field implementation would be bank swallow habitat found post-survey. So there is a landholder in the room where this did happen. We had plans in the fall to go in and do a bank restoration project. It was quite invasive. The following spring, we visited the site again and noticed that there was potential for bank swallow habitat that did not exist the previous year. We waited until bank swallows were migrating, we revisited the site and did find evidence of burrows being excavated. We immediately cheered and abandoned the project, but we had to pivot. So how we pivoted was Juan and I working together. There's not a lot of research on actually implementing restoration methods with bank swallows present. So we had to use the most up-to-date literature and talk to other experts in the field. And what we went with is just, leaving a little bit more of a buffer along the water. So we left around 25 to 30 meters where normally we would plant up to the bank pretty well. So we left a large enough buffer not to be really invasive to the bank swallows. And we also waited until they were done nesting and they were out of those nests. We also used shrubs and we used shrubs in the perimeter layer closer to the burrows, and we planted the hardwood trees farther back. So normally we plant at a closer density. We left a big gap, and we made sure that we left corridors for the bank swallows to access the grasslands. This is a pilot site, so we will let you know how it goes. We are working and communicating with Birds Canada as well. Another example would be bobolink presence. We have found bobolinks as a group, as an organization. We have decided that we would like to prioritize their habitat. So we have just left no management zones, and we are addressing erosion to mitigate the rapid loss of land. So sites that are losing more than a meter a year, there is an amount of soil, it's tons per liter, I believe, that that is an acceptable rate of erosion. If it goes past that, then we're focusing on making sure that there's land to preserve for species like bobolink. Okay, so just to summarize, in the spring and summer through this program, we have landholders contact us through targeted outreach. We arrange site visits with them. We listen, and then we make plans. We review the plans together, and then we start applying for permits such as WAWA and any other documentation needed. And then in the late summer, fall is when we implement these plans depending on the methods used. Sometimes, like I said, we do have to wait until the following spring. And this is, I'm sure we all know working in our field, it's also dependent on climate change, so it's very unpredictable. So this has to be adaptive. And then year two, we monitor, make added recommendations and implementations if needed. So thank you. That is our Natural Edge program. If you know anyone in the Nashwaak with riparian habitat, please reach out to us. And I'd like to thank our funders that made this possible. So community nominated priority places with Environment Climate Change Canada and the New Brunswick Wildlife Trust Fund.
All right. We're going to hold our questions just until the break, so please find Tanya and Juan and Daria if you want to talk to them further. But we will now move on to our speaker, who's listed as our keynote speaker. Sorry, Mark. With the role of erosion in critical habitat. So Mark Pulsifer is a biological consultant and a wildlife biologist from Nova Scotia, who is well known for his diverse background of environmental science, natural resource management, integrated resource management, and more. He's a retired professor from St. FX and the Nova Scotia Department of Lands and Forestry Project Development Manager. He now runs his own consulting business as well. So welcome up, Mark.
Thanks, Allison, very much. Well, this is great to be back again. I had the privilege and opportunity last year to speak to this group, and we can do it this way. That's better for those of you in the back of the room. I'm not used to speaking with a mic at all, so just want to say thank you once again. It's been a great opportunity to do this, and when I was contacted this year and asked if I'd like to come back and do this particular topic, I said sure, not even realizing really what I was getting into, to be quite honest. But Tanya was convincing, and I wanted to get back here and see Kate and see Ali and things like that. So, and I had such a good time last year. So I thought, why not do something like this? And so basically, what was kind of interesting about this is that it's a topic that just came out of the blue. And again, erosion, the value of erosion, what erosion means to us, and already we've learned a lot just in the first 3 presentations here today. And so I don't need to go over any of that, even though there was bits and pieces of each of those presentations that I was going to include in mine. And you've got a much better idea already of what's going on here than what I was going to talk about anyway. So I'm going to try to make this thing work. Push a button. Advance the slide. The green one. Okay. The big one, right in the middle. There we go. Couldn't be much more obvious than that. Anyway, so there you go. Professional keynote speaker, right? Can't work the technology. So anyway, I just wanted to start by saying that basically one of the things that we were already exposed to with this conversation this afternoon is that, you know, we learned from Juan that there's natural erosion, and then of course there's non-natural erosion or anthropogenic erosion, which is, you know, human-caused erosion. And understanding that both of those things are happening simultaneously is really important. And it's something that I hadn't given an awful lot of thought to, because quite honestly, when you're in school and you're learning about erosion, there tends to be a negative connotation with it, and so we hear about all the bad things that happen with erosion. We hear about things that Daria did a good job of explaining. We know about land use practices in general. We have stream banks that become destabilized and slump into water. We have basically land use practices where we build pads for all kinds of different things like mini homes that end up eroding and causing sediments to go into water courses. Highway construction, you know, perhaps in some respects, one of the biggest contributors of erosion and silt into water courses that are out there, and perhaps something that I'm kind of passionate about in the sense that I've worked a lot as a consultant on highway projects in terms of doing some of the biophysical work. And you know, when you see 20-kilometer stretches of double-lane highway left exposed with nothing on them, and then you have one of these 1 in 200-year storms that happens, unfortunately, they're happening way too often now, and certainly much more when you have a half a dozen 1 in 200-year storms that happen in the space of 2 years. That's in some ways with respect to erosion and how that relates to biodiversity in general, is that, you know, I find that there's more erosion, more sediment gets dumped into water courses as a result of perhaps some poor highway practices than anything to do with forestry or agriculture. And those are big ones itself. So just understanding that those are the processes that are going on out there. And again, Derry did a great job, I think, of explaining a number of different types of negatives when it comes to erosion. And here's just another project that I was working on, again, this highway project, by the way. And in taking a look at what's going on here, we know that erosion has the capacity to damage habitat, we also know that erosion has the capacity to create habitat. And so it's a dynamic system that's happening. A lot of these ecosystems that depend on erosion sedimentation are dynamic. There's good and there's bad. We know too that the results of these types of activities can also damage not only the habitat, but damage the individual, the bodies, the individuals themselves. And whether or not that's soft tissue damage, we know that they suffocate, they bury nests of invertebrates, of fish, they kill invertebrates, things like that. They change the morphology of streams. They contribute to increased water temperature as well. A number of different things. So I would like to make a point, though, basically of just saying that, we know that erosion can cause detrimental impacts in the environment in general, but there are also a number of different types of ecosystems that rely on it. And I wanted to focus a little bit on that part of it for the next few minutes, is that because erosion is a natural process, you would expect that there would be a number of different species out there that would have evolved with that type of disturbance. Erosion is a natural disturbance phenomenon, and so you will have species out there that depend on it. And so what I'd like to do, just if nothing else, just for the awareness portion of it, is speak to you a little bit about some of those different species that require erosion to actually go about and survive. And again, this is that aspect that perhaps people don't think about. And that's why I sort of started off this presentation a little bit with just 2 or 3 slides talking about the negative side of things, because that's often where we sort of fall into that trap. So I'm going to switch that around right now, and then this is positives. So here we have the first of what I have here is 5 different ecosystems that actually rely on sediment, erosion, deposition, and again, estuaries and salt marshes. And you think about that, so basically downstream flow, estuaries are nothing more than that combination, that mixing of fresh water and salt water. And so it's an interface between basically marine systems and freshwater systems. And when that fresh water comes down all those rivers out into these estuaries, and helps create these salt marshes, it's bringing all kinds of different nutrient with it. And some of that nutrient can be good, as we've learned, some of it can be bad. It can contribute to eutrophication if it's too much, but if it's handled correctly, if things are in balance, so to speak, then you're going to have positives come from that. And as a result of that, you're going to have birds, osprey, for instance. So in the Antigonish area where I live in Nova Scotia, we have some large estuaries there, and then, of course, estuaries are typically referred to as just being nursery grounds. They're high productivity, high biological productivity areas because of that nutrient that's out in these areas. And that nutrient is coming as a result of dissolved organic matter, particular organic matter, these different chemistries that are going on out there that basically are attaching themselves to sediments, and that they're ending up in the marshes and the estuaries themselves. And that's the basis for things like, obviously, for osprey feeding. Osprey like to feed on flounder. The winter flounder picture there that you see, that's a typical fish that's often found in estuaries. American eel. And of course, we have all kinds of bald eagles and things like that. And so when you take a look at this next slide, although it may be a bit washed out with the light here, but this is the Antigonish estuary that you see here. 2 big rivers that come out. And again, if it wasn't quite so light, you would see where the sediment basically was helping to build the estuary out. There was basically mud bars or sandbars. The estuary itself, again, basically has a lot of value for American eel fishing. This is a Mi'kmaq harvester, basically going out and fishing eel in the wintertime. And that's important. And then the striped bass fishery, again, like a lot of areas, certainly in Nova Scotia, I won't speak for New Brunswick, in Nova Scotia, the striped bass fishery is just taking off exponentially, basically. And so these estuaries, these nursery grounds, become very important ecosystems for fish as well. Coastal dunes, again, when you think about erosion, think about downshore erosion. This is Pomkit Beach. Again, you have piping plover beaches in Nova Scotia, here in New Brunswick. But again, keep in mind that we have species at risk in both of these provinces, such as piping plover, that rely on erosion. The sediments that are laid down on these beaches that are attributed to dune formation that are actually helping create dunes are what actually piping plover require. And so without that kind of deposition, erosion and deposition, without that type of structural habitat features on these beaches, piping plover may not do nearly as well, I suppose, considering they're an endangered species as they do quite right now. And so basically, when you look at this, you can, sorry, let's back up. This particular headland right here is what's actually eroding away and creating that beach. And when you look at this from this perspective, and again, I apologize, this is Pomkit Beach, but I will say that there's 50,000 cubic meters of sand deposited on that beach every year. 50,000 cubic meters, that's the rate of erosion in this particular area. And a lot of it was coming off that headland, but also coming off of other headlands further to the west, including even up here as far as New Brunswick, because a lot of that sediment is coming down from the northeast shores of this province and ending up in Nova Scotia eventually. And not only is that habitat created good for wildlife such as piping plover, species at risk like piping plover, but it's also creates other habitat features that are good for a bunch of waterfowl, wading birds, and things like that, amphibians. And the picture on the bottom right that you see there, that's in between. Pomkit Beach itself has a pro-grading dune system, which is it's kind of a big deal, basically, and it just represents different dune systems that have been deposited there for the past 1,000 years. And what you're seeing there in this particular picture in the middle, where you see the typha, the cattail, is those are called slacks. And in the slacks, you have water accumulation. In that water accumulation, you have all kinds of other things living there. So again, pro-grading dune systems in general. Juan this afternoon has already talked a little bit about bank swallows. And we heard more of that from Tanya. Again, banks are important, banks, cliffs, whatever. I just threw up another example here of things like bank swallows aren't the only bird that basically lives in these banks, and you can also have things like belted kingfisher that rely on this type of a habitat to basically to reproduce. These are nesting burrows, and we've all seen belted kingfishers around coastlines and things like that. So that's the third one. Freshwater wetlands, again, now this is one, particularly when it comes to the one on the left here, these are vernal pools. And again, this is probably one aspect of erosion that I hadn't considered necessarily in the past. And this is sort of the overland flow. So where you have water flowing overland, it's picking up nutrients as it flows. And basically these nutrients are being deposited in these shallow depressions that tend to be very seasonal, right? Vernal pools tend not to be permanent water bodies. And one of the more classic examples of species that live in these vernal pools can be fairy shrimp. And fairy shrimp themselves are quite uncommon. In fact, there's only 3 locations in all of Nova Scotia that have fairy shrimp, but they're specific species to vernal pools themselves. And then again, we have the classic type of wetlands, the freshwater marshes and things like that that are also very important for species of all kinds. Doesn't matter what it is. What I'm talking about here isn't just species at risk, but just biodiversity in general. And so again, as I said before, whenever you have water flowing over land or off the land into other water sources, you have nutrients that are supplied. And those nutrients, what's important about those nutrients is that the nutrients that the water brings with it through erosion is actually what fertilizes those systems, that nourishes those systems. So it becomes the very basis of food chains. And so if it starts at the bottom of the food chain, it's actually benefiting something through several layers above. And so as you get to the apex areas of these food pyramids and things like that, it's just not a few different species, it's hundreds of species, if not thousands of species that are actually benefiting from erosion itself. And here's an example again of a wetland system and a species at risk, the rusty blackbird, probably one of the species that's declining more than any other, in Canada in general. It's endangered in Nova Scotia, and I think it's vulnerable here in New Brunswick. It doesn't have quite the same level of conservation status as it does in Nova Scotia. But again, here's a species that relies on wetlands, I guess, basically for nesting and feeding in the vicinity of, basically, particularly softwood boreal type wetlands. And this particular species isn't doing really well right now. So it requires good, biologically productive wetlands, whether or not those are wetlands caused by beaver or created by beaver. In this particular case, this is a beaver pond, or they could be more naturally occurring. Eastern ribbon snake is another one of these species at risk, basically, that's depending on where jurisdiction you're in, it's either endangered or vulnerable. This is another wetland species that benefits from the increased productivity and fertility of wetlands that are nourished by overland flow stemming from erosion. Water courses and floodplains, another system here. I mean, I think you're getting the pattern, right? Basically, erosion in some ways, and sedimentation, and overland flow, and nutrient transfer, and things like that are benefiting all types of different kinds of ecosystems that we have out there. And again, water courses, we have, I'm using American woodcock as an example here of a species that benefits from seasonal flooding of the banks, overtopping the streams themselves, and carries nutrients with it that make the particular ecosystem highly productive. And woodcock are one of those species that like to feed on worms, for instance, and small invertebrates, and that benefit from that. Same as Canada warbler, again, the more classic hardwood floodplain on the right. Here's another species at risk that relies on the increased productivity that benefits as a result of increased erosion and sedimentation, seasonal erosion and sedimentation. Again, as you've heard at least twice, if not 3 times already today, that erosion has its benefits. Basically, it brings nutrients with it, and those nutrients actually start somewhere at the capitalizing the benefits actually start near the bottom of the food chain and work their way up. And so there's all kinds of different food types that benefit from that. Now, I wanted to talk a little bit about a couple of different topics when it comes to erosion and how erosion is important. And basically, specifically, I'd like to pull up ones that people may not know an awful lot about. Nova Scotia and New Brunswick, we actually have 10 different species of freshwater mussels. And freshwater mussels are kind of neat in that they, of all the species at risk, of all the species in North America, the freshwater mussels as a group are the most imperiled. They're the most endangered right now because of land use practices, because of deleterious practices. They're filter feeders. As a result, then because they're filtering literally many gallons of water a day, liters of water a day through their systems, they become bioindicators of healthy environments and things like that. And one of the things about, of course, that's kind of neat about freshwater mussels is they also require fish to act as an intermediate host for the larval mussels. And so basically, the mussel itself, basically, it fertilizes eggs so that larvae are produced, and those larvae are shed out into the water or into let's just say into the water in general, where they're picked up by another fish. So a fish actually carries these larvae around in their gills until the larvae, these glaucidia, basically mature enough in size, and they absorb calcium carbonate, calcium from the water column, and then they drop off into the sediments that you find in the water. And then they grow there. And so they fall into the sediment, the sand, the silt, and after they grow there for a bit, they become certainly something you can see here. And so when I look at these, we have 3 or 4 different species here in in New Brunswick. These are the same species we have in Nova Scotia. The yellow lamp mussel is imperiled. We have the triangle floater. We have things like the brook floater, and then we have basically tidewater mucket. So there's 4 different species at risk that live here in this province, all requiring habitat created by and through erosion, sedimentation, all required, have fish hosts that make them particularly vulnerable. The fish have to have good habitat to survive as well. And so I use brook floater just as an example here. And so brook floater like to have sand deposits, sand and gravel. They like to, I guess, live in those. They function in those. They bury themselves in the wintertime in that sand and gravel, and so they need erosion. They need that deposition in order to survive. And then in the spring of the year, they come back to the surface again. And then they can actually move around a little bit within the water column itself, or sorry, not the water column, but within these lenses of sand. And so these filter feeders are really incredible in the sense that they each have their own requirements depending on what they are. And so I just said that basically brook floater is a species at risk. It requires sand and small gravel. Eastern elliptio gets along really well. I guess it really basically requires sands. And then the eastern floater, it's called a floater because it's called a floater because it tends to float a little bit on the sediment in the sense that it doesn't have a very thick shell. It's not a heavy shell, basically, and so it doesn't sink far, and it's actually able to adapt and live in small, I guess, in areas where you have small sediment, basically like silt and fine sands and things like that. So the point is that erosion's happening and it's creating these different conditions, and other animals are finding locations where they can survive and they can fit well. Another example of how erosion has come to pass in the sense that sometimes we have conservation requirements for one species that unintentionally interrupt a second species. And I want to just bring to your attention here a little bit this, it's not really a conflict, but at the same time what it is that we tend to look at Atlantic salmon in some ways, and then we have wood turtles that have sort of competing needs. And the way that we manage for those species sometimes creates some problems. So this is an area that I wanted to show you that in Nova Scotia, this area here, this beach that I've just circled in that red, used to be the highest density of nesting wood turtles in the world. That beach every year had 32 to 35 nesting female wood turtles. And that's the one location in all the world. And those wood turtles were nesting in sand and gravel deposits on those particular beaches. On that particular beach, that was the result of erosion further upstream, bringing sand and gravel with it downstream. And we could rely on every year that we would have enough erosion particularly erosion from ice scour would erode away the banks. But again, here we had a situation where number one, the farmer who owned some of the land in the area was concerned about losing his land, and so he basically didn't want to see that happen. And then we had Department of Fisheries and Oceans who were worried about fish habitat. And so the solution became to rock the banks, to harden up the banks, and so to prevent that. That was both the landowner, the farmer, and the federal agencies were happy that erosion was no longer happening. Unfortunately, when that happened, we lost something. We lost a source of deposition. So what had happened in the past is that ice had come down that river every spring and scoured away all the vegetation. Thank you, Kate. Would scour away the vegetation, and from that, and that was the source of sediment that these turtles were nesting in. And then secondly, we had the loss of ice itself, because climate change being what it was, there was less ice coming down the river. As a result, now this particular beach has become highly vegetated as a result of no ice scour anymore. No sand and gravel is being deposited on there anymore. And therefore, the number of turtles that nest there now is not 32 or 33 anymore. It's something about a third of that. Another example of competing management strategies. We have this is an area of the St. Mary's River. You can see in the top left corner and over on the right-hand side, the river is approximately the same width. That's about 50 meters, but there's a big section in the middle here that unfortunately, after they put the bridge in here, it caused a lot of erosion. And what's happened is the erosion in this particular area has really impacted these two nesting turtle beaches on the right-hand side of the image there. And so right now, I'm working with the St. Mary's River Association and another consultant to try to come up with a way that which we can move the riverbank, or at least channel the riverbank here in the middle of the photograph to one particular area rather than have 2 or 3 different channels. And so that and at the same time do that, we don't want to be losing the wood turtle nesting beaches that we already have. So again, it's a real world example of trying to manage 2 different species with competing needs at the same time. And I think we're getting there. We're going to come up with a solution. Again, I mentioned hardening the bank. This is another one of those situations with respect to wood turtle that this is typically what happens, is that you'll harden the bank with large stone, armor stone, which is great from the point of view of keeping the bank intact. But what happens is when turtles get in between those rocks, they don't come out. And so we noticed that in some particular cases that small turtles, basically if there was a nesting beach nearby, they might fall down in between those interstitial spaces in the rocks, and they would have a hard time getting out, or they wouldn't get out at all. And so what we've done is we've recommended top dressing the larger stone with smaller gravel. Again, which fills those areas in. It's a very practical example of how you can basically contribute to the hardening of the riverbank and not basically create these ecological traps for turtles. And again, just to finish up here, hardening the banks is something that happens. This is just pictures from downtown Antigonish. On the left, people would use old sidewalks. They would use pieces of asphalt. All of these things they stabilize in some areas, but at the same time, they also create other erosion problems somewhere else. And so you're just moving the problem around as much as anything else. And again, some other examples that you routinely see. I threw in a couple of things I just pulled off the internet just for the sake of it, getting away from armor stone and things like that into more natural bioengineered solutions may be a possibility depending on the scale of the project. And going back to those of you that work in forestry will understand or recognize, I guess, basically the use of riparian areas as being particularly valuable in terms of stabilizing stream banks, whether or not it's water courses or actually water bodies, by keeping the vegetation intact. And in the same way, the picture on the right is a picture of an agricultural field, basically that the farmer has kept the riparian zone stable, I guess, basically by leaving about 15 meters of shrubbery along there, which has done a really good job. Not all erosion is bad. Many species depend on erosion for their very survival, so keep that in mind. Erosion creates really important, critically important habitats, and so sediment transport is going to help nourish those habitats. So I said there were 5 different ecosystems that were basically dependent upon erosion, so let's keep that in mind. Disturbance-dependent species, as I mentioned before, require erosion. They require those dynamic changes that are happening on the landscape. When we try to intervene as people, as humans, we sometimes can create problems that are unintentional consequences and things like that. So again, keep that in mind, that we can inadvertently create habitat traps and ecological traps. Erosion, again, can bring with it its own issues when it comes to stabilization. And that for sustainable, if you want to be really sustainable when it comes to this, just keep in mind that we can protect our infrastructure. We can, if we think about it though, we can protect our infrastructure and still be able to, I guess, conserve biodiversity habitat in general. We should just look for solutions that try to do both. Anyway, thank you very much. After, yeah, okay.
Thanks very much, Mark. For anyone just joining us, come on in, find a seat, don't be shy. There are name tags and stuff on the table if you want to find them, or find them at the break. We're going to move right along to our next speaker, which is Donnie McPhee. We will have time for questions, so just write them down if you have any. We will have a discussion panel towards the end, and we can do some question and answering time then as well. We just want to keep on track as best as we can. All right. right. So after Donnie, we will have a break for refreshments, and you can find the speakers and ask some questions then as well. So Donnie McPhee comes to us as a recently retired manager for the National Tree Seed Centre at the Natural Resources Canada. He's also a member of the Burr Oak Restoration Team, and to loosely quote Donnie, he now gets to be fun in the field, or have fun in the field and work on the projects that he chooses. So we're happy that you're here today with us.
Great. Well, it's really nice to be here. My first time to stand up since I retired after 40 years working with the Canadian Forest Service. And as Allison mentioned, my last part of my career was managing Canada's National Tree Seed Centre, which is a conservation organization looking to preserve seed from all forest and shrub species in Canada. And it's located here in Fredericton. If you haven't been there for a visit, you really should. It's a gem in your backyard. Yeah, so I'm here representing the BORT, or the Burr Oak Restoration Team. And this is a kind of an ad hoc group that was put together back in 2018. These are the current members who organizations who attend, I'd say, a quarterly meeting, but we've had about 25 different organizations, including our Indigenous communities that are along the Woolstick River, JDI, UMB. There's been all kinds of people coming in and out, but this is sort of the core team. And I'll put this slide back up at the end. If any of you have any questions, you can reach out to any of us that are on the group. So our vision is to restore Burr Oak back to its natural, and I'd say right place on our floodplains of the St. John River Valley. This kind of map here is just showing, based on climate change scenarios and stuff, areas where Burr Oak should do really well and should be considered as a species when you are looking at land reclamation, especially on our floodplain ecosystems. When I say restore back, well, I guess I'll get in first of all. Has anyone here not know what a Burr Oak tree is? Yeah, so it's the only white oak native to this part of the world. It's only currently located naturally in the St. John River Valley along the Grand Lake ecosystem. We have our northern red oak here as well. The biggest difference is that when you look at a Burr Oak, it really is here in the Maritimes. It's built for the floodplains. It has very thick bark that protects it from things like ice scouring. The acorns are highly palatable, so almost all of our wildlife eat them. But also, Burr Oak, you can buy Burr Oak flour if you go to like a natural store. It's very palatable. And a lot of the First Nations communities in this region, actually, it's known that we didn't have a lot of corn or stuff, but Burr Oak acorns we pounded and used into a flour. It grows very tall, and I'll get into it, some of the other characteristics of what makes it a great floodplain species here. Great for wildlife, enhancing biodiversity, improving soils, and palatable fruit. So, and this presentation, I think these are going to be made available to people. Yeah, so I'm not going to read everything that's on the slides because I'm going to ramble on when we get into this a little bit here. So for erosion control, so Burr Oak, I call them the iceberg on the land. When you think of an iceberg, like 90% of what you see in an iceberg is below the soil surface. It's almost the same for Burr Oak. When you plant a Burr Oak, its first 3 to 4 years, everything is root development. It'll put down a 10 to a 15-foot root in 3 to 4 years. So a lot of people, after they plant Burr Oak, they go, oh, they're not doing great, because they're still only 2 or 3 feet tall after 3 to 4 years. But if you tried to dig one up, your root system, and it's just an elaborate root system, which is really great for holding riverbanks together and for stabilizing our floodplains. Whole bunch of other things here of why it's good. I mean, I mainly put these up so you guys would have them when you left here, but it's just a super adaptable species. So this is sort of its native range. It's the most widespread of all the oak species in North America. Its contiguous range sort of starts around Montreal all the way to Manitoba, funneling all the way down. But over here in the Maritimes, it existed on our floodplains off the St. John River. Yeah, so this in itself leads to, and again, I'm going to ramble a bit here. When I talk about restoring bur oak to the floodplain, one of our biggest issues is it only produces seed every 3 to 5 years. The acorns only store for 1 winter. So a lot of the local nurseries, including the city of Fredericton, who have done a lot of work planting bur oak, if it wasn't in seed here, they would buy it from Southern Ontario. If it wasn't in seed in Southern Ontario would import it from the south. And so basically any plantings that were done in the northern part of Canada all around, that seed source, we never knew where it was coming from. And it would get a real bad rap in that only about 10%, if anything planted in the cities and stuff, was surviving. And people would blame that on, you know, improper planting techniques and stuff. And it's like, well, no, it's probably just not genetically adapted. You're bringing in seed from Texas, from central US, and expect it to grow in our winter habitats up here. And it just doesn't work. So if you take any take-home message from anything I say here is we need to be using local seed sources. And that's something I can help you with if you are looking for local seed sources. Yeah, so back in the late 1990s, in my role at the Canadian Forest Service as a conservation geneticist, we actually did a genetic diversity study because in New Brunswick, there were really only 7 small pockets of bur oak left. So we did a genetic study comparing them to other populations in New England, which are also small. And then we compared them to populations within the native range. And what it did show us is that our bur oak here was unique, genetically speaking. And it also, everywhere else in the south, the acorns fall from the tree and they germinate that fall. Whereas the bur oak here in New Brunswick, the acorns fall, they do not germinate right away, because if they did, they would probably freeze. So they wait until the spring to germinate. So that's another reason. We were doing a lot of using bur oak from elsewhere to plant here and then wondering how come they weren't regenerating is because they were dropping their seed, the seed wanted to germinate, and they were basically being frozen out in the fall. These are sort of the, in 1990, the populations that currently existed in New Brunswick. And something I should mention too is that the historical data, so Simard and Boucher from Quebec produced a paper back in the early 90s showing that, and this is a history lesson for you, but at the St. John River Valley, there was more bur oak wood exported from 1800 to 1810 than all other species combined. So for some reason, it was just harvested to almost to existence during that short window of time. Some of the older papers, like Moses Purley, you know, going up the St. John River, he mentioned in his papers before that time about how there was white oak everywhere along the St. John River Valley, but then it just completely disappeared. And that's because we overharvested. There is no insect, there is no disease, there is nothing like that to take care of it. It was basically us clearing the floodplains. 5 minutes, that goes by fast. So some of the work we've been doing since that time is we've been working with watershed groups, working with Indigenous communities. So up here, that's up with Peel Ground. Up in Red Bank, we actually restored a garbage dump, but basically showing using New Brunswick seed sources, how well they'll do. So in my time with CFS, we planted about 60,000 bur oak, and that would all be these little blue triangles, but a lot of the other, like the stars and stuff, that's, I know it was shown earlier, the Nashwaak Watershed has already been planting a lot. It does survive really well. So this is a 5-year survival. So this was in 2002, but really high survival rate as long as you plant them properly. So that's another reason, because they put in such a great taproot. A lot of times people are growing them in pots for 5 or 6 years. They become root bound and then outplanting. With bur oak, you could collect the seed in the fall, start them in May, and by July, you have a 3-foot tall tree that you can plant. And that's when they do best. Yeah, so I get time, I'm right on now. Yeah, so I'll be here to talk, but as I said, this is a little picture, you already saw it earlier, of Nashwaak Watershed planting up near Marysville, I believe. But one of our biggest thing, and we work with JDI, we work with Canadian Forest Services, we have seed orchards now planted that are all coming online, so that if seed is required, you could reach out to myself or anyone else on this, sorry about that, or anyone else in this group, and we can probably help you out in finding the seed sources that you need. Done.
Thanks, everybody. We are 2 minutes ahead of schedule, so we do have time for a question or two if anyone is interested, or we can just break early and come back after. Let's break early. All right, we'll give you about 10 minutes, and then we'll call you back to your seats. Thank you. $19, $18. I shouldn't have had sugar. I'll be like, when I go to I get the big thing. So there's really I'm just breaking up. Okay, everyone, we're going to get going again. So our next speaker is David Roth. David is the New Brunswick Program Director for the Atlantic Salmon Federation. His academic background in Atlantic salmon research makes him incredibly knowledgeable in erosion, siltation, and how they affect fish species and habitat. Thanks, David.
Hello, everyone. Actually, I didn't know too much about sediments before coming here, so I was like, my scientific background is more telemetry, supplementation, but many years ago I did an undergrad in bioengineering, and a couple of things were still present there. But it was really good digging into the topic again and summarizing a little bit of my findings to you guys today. So as Mark already, this button. Yeah. So as Mark already did an excellent job about talking natural erosion versus anthropogenic elevated sediment inputs, it is a natural occurrence, and it's very much needed. And because Mark did such a good job already in his presentation, I might be able to talk a little bit, take a different angle to it as well, where I originally come from, Switzerland, and I worked across Central Europe a little bit. For example, Switzerland is half the size of New Brunswick. We have 9 million people living there. So when I initially came here and heard about restoration projects, I was like, where? Because for me, everything looked pristine. A couple years in, that obviously has changed. There's great work being done, and it's much needed. As an extreme example, for example, where I come from, to kind of tell like how important the work is that all the people here in this room do is, on my home river, the River Rhine in Switzerland, Basel, because on that river we have 32 run-of-the-river plants, hydropower plants. There's not a lot of sediments going through there, and you have impoundment after impoundment after impoundment, plus hard riverbanks. We have big cities, hard riverbanks, not a lot of nature left, so we often have the problem that we don't have enough input. And it leads to this ridiculous phenomena where the stretch where I'm from, the Basel stretch, they have to dump every day. There's a massive container ship that goes up to the dam and dumps gravel into the river. And it's a massive river. And the gravel travels down river and then gets caught up at the next dam. They excavate it out to bring it up again. And if you wouldn't do that, that protective function of that sediments, gravel, and other coriotype classes have to protect the soul of the river so the river doesn't dig in. If you wouldn't do that, the river would dig in and it would break through and basically go underground. So this is kind of the extremes where in my previous life before I came to Canada, some of the implementations that we had to do. So, but digging into the topic, and there's a lot of research being done of it. So, and then from one of those publications, I'm using this figure, which does a pretty good job in summarizing effects of sediments they can have on fish. So I'm going to talk through different life stages, how it affects the fish, and so there's a lot going in. And the sake of time, I'm going to go through different points for different life stages of fish. One thing that I added that wasn't in that publication was pollutants. I'm going to talk a little bit about in relation to fish in different life stages, specifically heavy metals. And because I work for the Atlantic Salmon Federation, I'm going to use the life cycle and the simplified life cycle here of the Atlantic salmon and how the different life stages are affected by sediment input or extra anthropogenic sediment input. But I'm also going to refer a little bit to different fish species, because you can imagine there's different genuses and they have very different approaches and different life stages, and they're going to be affected differently. So I'm going to make some cross references to other fish species as well. So for most fish, life begins in an egg that is deposited somewhere in the water. For Atlantic salmon, female digs a red, the eggs are deposited in the red. It's covered. Other fish species just lay their eggs on top of the substrate. Other fish species have sticky eggs that they attach to macrophytes. Other fish species like striped bass here in the Woolastock River, the eggs go into drift in the water column. So anthropogenic elevated sediment input. What are the issues for at the egg stage? So the first one in here, increased sediment deposition, infiltration of substrate, their interstitial space, increased BOD, reduced oxygen supply. So the eggs, no matter where they're sitting in the water, if they're in the gravel, if they're on top of the gravel, if they're attached to a plant, if they're in the free floating in the water column, they are dependent that there's water flow around them that supplies them with oxygen. So as you can imagine, if there's a layer of sediments on top of the gravel, that might prevent the water flowing through the red, no oxygen supply, and the eggs might just die. So this is particular for eggs that are in the water column, maybe not that big of a problem, but for eggs that are deposited in the gravel, on the gravel, can be a very big problem. And maybe something that I skipped, which is really like, no matter where you follow like this anthropogenic elevated sediment input, it leads kind of to reduced productivity at higher trophic levels, reduced animal and plant abundance, species richness and diversity, and shifting community composition. So like big topics, big problems to come along with it. So the next stage in the life cycle for Atlantic salmon would be the alvin stage. For other species, it's commonly the larvae stage of the fish. Again, for Atlantic salmon, what they do, once they hatch from the egg, they actually dig themselves into the gravel. They're going further in. The reason why they do that is, at this life stage, there's no exogenous feeding yet, so they're fully still feeding on their yolk sac. But there's a natural occurrence here every year in spring, you have the spring flood. And that's where like natural, like as you mentioned, ice scouring and everything, but this ice scouring can also dig out the reds. The increased discharge can completely turn over a salmon red, and the eggs would just be flushed out. So that's the reason why they dig themselves further down to be protected from those spring floods. For a lot of other species at this point in life, the swimming capacity is very limited, and they just go into drift. And they end up somewhere in a backwater flow, slow flow velocity, and that's where they're going to be in the beginning of their life. So as you can see, they can't just escape, like they're trapped. But then at the, I guess, shoop. Yeah. So increased suspended sediment load that again, like will deposit, infiltrate the substrate, reduce oxygen supply. So, but besides that, a problem can be if you have that closing layer of fine sediments that clog the red. Once the alvin stage is over, they might not be able to come out of the substrate. And that's other species that have their eggs in the substrate might be the same problem. So they might just be trapped. As soon as the yolk sac is absorbed and they need to switch over to this external feeding, they literally starve. So after the larvae stage, for the Atlantic salmon, we talked then fry stage, young of the year, then switching over to par. So now they're out. Now they emerge from the gravel. Just click. And now they start. Now they actually start feeding. So all of a sudden there's a big change. So swimming capacity has increased. If you think about fry, still swimming capacity, there's some now, but still if there is a direction where the fleeing reaction, it's mainly downriver. It costs them a lot of energy if they're dislocated due to, let's say from a road, sediment input, and they have to abandon the space. They will go downriver and not necessarily come back because simply they don't have the swimming capacity at that stage. Later, when they're par stage so on, they can travel longer distances and they have bigger fat reserves, but there can be dear consequences at this early young of the year life stage. So there is now other issues that are at play. So increased suspended sediment load, so increased turbidity and light attenuation. So a lot of fish, they're depending on food that is drifting by, and that's what they feed on, juvenile Atlantic salmon. So increased turbidity means less visibility. It's going to make it harder for them to identify a prey and go after it. So they might have reduced growth rates. Another thing that is mentioned here is damage to plant and animal tissues. Animal tissues was mentioned before in the presentation for specifically, and there again it depends on what life stage you are. For juvenile fish, increased sediment load can be really problematic, mainly for the gills. The gill can clog up. And again, they don't necessarily have the swimming capacity to just like see you, and I'm just going to come back at a later point. If you have an adult salmon, for them it's no problem, or suckers, chubs, all kinds of species. Adults, they can avoid this and come back. Again, for a juvenile life stage of all fish, it might have dear consequences that they have to abandon the preferred site. They end up in a location where the conditions are not as favorable and have reduced growth rate. And if in extreme case, again, die due to that dislocation. What else? They have reduced benthic invertebrate density and increased drift. So again, just because those micro niches might be clogged up due to the sediment input, your kind of food chain can completely collapse. You might just not, for salmon, relying on insects or in early life stages, they might not be there anymore. So they have to abandon the habitat because there's not enough food around. So that goes also with the loss of physical habitat. So dear consequences there. Then, talking about pollutants. Here I'm addressing it for the smolt life stage for Atlantic salmon. This is when they transition, when they leave the freshwater habitat, they migrate out the rivers to the oceans. It's called the smolt life stage. And there are specific problems there can be anthropogenically created is like acidity and other heavy metals that get, how you say in English, dislocated because of the increased sediment input. And for smolts especially, one challenge for animals, for example, like anadromous or diadromous fish that have the ability to live in fresh water but also salt water, is the osmotic regulation. So one thing where you actually actively try to keep minerals in your body, and the other one where you're like, okay, it's like now I'm in salt water, I don't want to have all this increased salt in me, so like oversimplified. And that transition can be quite intense. And there is research that show increased mortality rates during times of smoltification for Atlantic salmon if they're experienced lower pH values than would naturally occur, and specifically also linked to increased aluminium presence in the water. Another example, for example, here on the Woolastock River, where I did with a colleague, we did a study and published it, and it's linked to the Nashwaak Dam, is mercury, and was also with DDE, but we did that study where we looked at, okay, there was early work from Mike Dadswell, and even before that in the 70s, that indicated problems with mercury and DDE in the system, which led to the egg quality being so bad that even when spawning occurred, the eggs failed. So complete year classes, the spawning reproduction failed. So again, can influence all species in the water, obviously. So for adults, and so I skipped the oceanic life cycle because I'm focusing a little bit on the riverine environment here. Of course, like when it comes to sediments, there's also, like as Mark alluded, there is like the coastal. You can also have lake environment, and that is again like completely different topic and stressors in effect there. But adult salmon come back to the rivers to spawn. So here becomes again increased sediment deposition, the surface smothering, infiltration of substrate, loss of physical habitat. And like the salmon are capable to remove sediment out of the red that they dig. But if you have additional input, again, it will just cover up, and eventually you have again the problems where I alluded to with the eggs. Other problems that I talked about, like if there is temporary increase in sediment, those guys can just go on a little trip downriver, upriver. They have the capacity to do that without necessarily drastic consequences. It can be really drastic during times, which is a topic these days, I'm sure that all of you have heard about, during heat stress events, and that's for a lot of cold water species, where you have, if it's adults or if it's juvenile cold water species, by the thousands are cramped into very limited space. For example, at cold water plume from a tributary coming in. And if at that moment in time, that tributary has an increased sediment load that is above the capacity what the fish tolerate, and they have to abandon that thermal refuge, that can have dear consequences. The last picture here is just an example that I was involved this year. It's on the Nipisiguit River, and there is a dam from NB Power, and this year they were removing a cofferdam. And during the work that they did, they have to monitor the sediment load downriver. They didn't do a really good job, and a camp downriver saw you can see here the red is back, huh? They increased sediment load and reported it, and they had to stop all the work that they were doing at the cofferdam. This was particularly problematic because the Nipisiguit River already lost its entire population a couple of decades ago. It was a hecton of work to get the Atlantic salmon population back to state where they're self-sustaining. The problem is the main spawning routes, hundreds of reds, are literally a couple within sight of the dam, downriver of the dam. And I guess all of you have been on the river last year. There was not a lot of water flowing. So the deposition rate was even higher than in usual years. So we were very worried, and we had an eye on how that's going to affect the spawning sites just downriver of the dam. And you can't solely necessarily blame it on the increased sediment deposition that had occurred. But in here you would have a lot of reds, usually where you would have hundreds of reds. This year there was a handful of reds there, and a lot of the reds we found were further downriver in what we usually would define as less suitable habitat for spawning for Atlantic salmon. So I hope I gave you a little bit of an overview. It's a very complex topic. There are other species that are completely different affected by it, but that would be a little bit too long today, but I gladly take any questions.
questions, if anyone, there's actually a microphone just set up right there, if you want to pop up to it.
In that example there with the dam replacement or the culvert replacement, was the total number of reds affected throughout the whole water course, or was it like, did they just move, or was there an actual reduction in the number?
It was an actual reduction. It was different locations and actual reduction, but it's like, as always, it's like, scientists say it's complicated. It depends. So we had very low discharge regime as well during the main spawning season. So that probably played into it as well. Yeah.
Okay, thank you.
No problem.
Where did the mercury in the lodestone originate?
Other people might know in this room might know the answer more, but there is a phenomenon called, if you have an impoundment and you have organic matter that gets flooded there, that don't know the English term for it, but it's one of these common known things. Mark might know. How's the phenomenon called if you have like heavy metal that get dislocated if they're submerged down? No, there's a specific term that's like once it's an anaerobic, like organic matter in an anaerobic environment, that it kind of frees heavy metals again. That's where I assume where it comes from, but nobody has really looked into it. Okay.
Very good talk, David. Could you talk about the very large decrease in the salmon coming up the Dungarvan River? Any information on that? Because it's huge. Decrease this year, and other years just going down fast.
It's a very different topic. Thankfully there it's not due to sediments, but it's in the Gulf region overall, and we have record low return rates everywhere in the Gulf, mainly in the Miramichi, but it's something we're working on. We started a couple of new projects, and it's mainly due to predation events during outmigration at the smolt stage that we're losing a lot of juvenile salmon going out to the ocean. So now we're transporting them on the back of a truck.
Thank you.
Okay.
Any other questions? Any online, Tammy? No, but we do have some for the panel, and if people come up with more, we can ask them. Okay, all right. Thank you, David.
You're welcome.
It's never a problem to be ahead of schedule. So up next we have Donald Baird. Dr. Baird comes to us with a background in wetland ecology, stress ecology, and global change processes. He obtained his PhD in ecology from the University of Glasgow in Scotland. Currently, he is a visiting research professor at the University of New Brunswick in Fredericton, a fellow at the Canadian Rivers Institute, and is also a senior research scientist at Environment and Climate Change Canada. Not anymore? Darn. Your LinkedIn lied to me. It's okay.
No, actually, I'm one of many, I think the third person, who's retired from government science, so that's spoken so far. Anyway, good afternoon, everybody. Thanks very much to the Nashwaak Watershed Association for asking me to give this presentation. I was, a bit conflicted in the sense that it took me a little bit out of my comfort zone. Also realizing that I'm the last speaker of the afternoon, that probably many of the things I'm going to talk to you about have already been presented by others. And I think that's an advantage because it gives me an opportunity to re-emphasize some of the excellent points like the previous speakers have made. But anyway, so that was just a photograph I took on Marysville Flats last week, where you can see ice basically breaking up on the river, and evidence of the kind of maybe not much of an ice jam or much erosion effects this year, but certainly it was enough to destroy the cycle track on the Gibson Trail, so there'll need to be some remediation work taking place there. I'm a keen observer of the Nashwaak River, mostly because I live downtown and I usually go out about 5:30 in the morning cycling the loop around Marysville. And sometimes you run into some interesting things like this snapping turtle that blocked my path one morning. But anyway, I see that it's a bit of cut off here. Sorry about that. If we can we move the projector over a little bit? Is there anything that can just center it? Yeah, that's it. That's enough. Great. So just to give you a roadmap of what I'm going to talk about, I want to firstly talk about why riparian edge habitats are important. We've heard a lot about this morning, but I think I'm going to talk about maybe some different aspects that could be of interest. I want to give you an example of the critical ecosystem services that they provide. Just a very short couple of slides about one of my PhD students, a project that we're actively involved in on the Nashwaak at the moment. I was going to say a little bit about riverbank erosion 101. I think you've probably heard it all, but again, it's very short. So, and then talk about natural and human causes of bank erosion, which again has been covered a little bit. And then I want to finish off talking about implications of future climate, because obviously talking about erosion with the types of processes like ice jams, storm events, and so on, what's coming in our collective future. But again, some of this stuff's already been covered, but I want to emphasize the importance of river floodplains. River floodplains have been a main focus of my research over my career, and you know, they're just such a fascinating and critically important environment to work in. This is a diagram that I stole from a paper by Rick Hauer, which looks at, it's talking mostly about gravel bed rivers, kind of the types of things you see probably in Switzerland, actually, David. But I think makes a nice illustration of the different things that are important. Oh, sorry, that's back. Let's just try to get the pointer here. Must be this one. Okay, I'll just point. If we go from the bottom clockwise, you can see the first one looks at microbial processes that are going on in sediment on the edge of the floodplain that allow recycling of nutrients. The second one showing habitat provisioning for macroinvertebrates, things like upwelling of groundwater can provide habitat, and again that requires certain characteristics of the channel in order to support that. You know, David just talked about spawning reds for salmon, the provision of perching habitat and other bank habitat for things like kingfishers or bank swallows. The importance of these areas outside, and I'm going to be talking a bit about these in the Nashwaak particularly, the kind of wetlands that form like bogans or other depressions that are connected to the river provide important habitat for many species. The floodplain also provides browsing habitat for many herbivores. And again, one of the things I found, you know, living in Fredericton, it's kind of amazing that we have a river so close to the center of the city that has so much wildlife, even close to downtown. And so we don't actually have wolves and caribou here, so you can ignore that one there. But it's just, so there are many aspects of the river floodplain that help sustain different types of wildlife. And it's very important to know when we're planning to do things in the floodplain, when we put in structures or we do land management or whatever, how these things are likely to be affected, so we can at least plan to mitigate effectively. So looking at river floodplain habitat, this is just, again, this is Marysville Flats, so it's on the Nashwaak. I just wanted to again, just remind you, the floodplain, you know, extends right across here. Where I'm standing would be the Gibson Trail, you know, the cycle trail, and it goes right across into the fields on the other side. And every year, this whole area is like completely inundated with water. But obviously, once the water recedes, then these habitats, like these riparian wetlands, these actually occur throughout the summer and provide critical habitat for many species. not just aquatic species, but also for terrestrial species in terms of food supply. So I just wanted to give an example of work, I said, that's ongoing at the moment. Currently, we're doing work at a number of sites on the Nashwaak. You can see from this Google Earth diagram here, we're looking at Hyla Park that's not actually part of the floodplain. So I keep that in mind. It's actually disconnected. It's more of a borrow pit or a quarry that's been kind of converted. Greenwood Drive, Neil's Flats, Marysville Flats, and much further away, Nashwaak Meadows is a kind of far-field site. And we're looking at how these different wetland habitats along the river floodplain contribute insect productivity for aerial insectivores, particularly birds and bats. So we've been obviously monitoring birds and bats within these systems, and we've been sharing data. We shared a bunch of data, I know, with the Watershed Association who are interested in this. But what we're interested in is looking at the costs and benefits in terms of fatty acid provision, which are really critical for early development of both for bat pups and also for bird nestlings. And also the interaction between food quality and mercury, which is obviously has no nutritional value and is in fact toxic. So that's something that we're looking at the moment. We're looking at this in the Nashwaak. We've also done a little bit of work on the Nashwaak Sis as well. And that's my PhD student there, Tamarazi. So in terms of aerial insectivores, we've been looking at, so we've been observing in our sites. If you're interested, with the bat recorders that we set up, these are the 5 species that we routinely record. There's been a lot of activity at these sites. We were quite surprised actually about how much feeding activity there is. So the bats are obviously feeding in these habitats. And also, I just give an example of some of the more common and important aerial insectivores that are also using these sites. And you can see we had a little thing last summer with tree swallow nesting boxes, but not too many of them got occupied. I guess there's no housing shortage for tree swallows, I think, in the Nashwaak. So, but at least one posed kindly on top of the nesting box so I could take a photograph of it. So we're interested, you know, and again, this is all I want to say, just as an example of how important they are. We put out, any of you who go for walks along the Nashwaak may have noticed these things in the little pyramid-shaped things in the water and the wetlands along the shore. We're using this to catch insects, and then we're looking at the fatty acid content, biomass. And if you look at the graph in the top right-hand corner there, I just wanted to illustrate the importance of these habitats. The kind of the line in green is Marysville Flats. In terms of insect production, and basically there's actually more insect production coming out of these wetland areas than from the river itself. And as a comparison, Hyla Park, which is not connected to the river, it's not part of the floodplain, doesn't have any interaction with erosion, sediment production or whatever, very, very low productivity in that system. So these fringing wetlands are what you might call part of the foodscape of the system, and it's very important that we're conscious of that when we when we carry out different activities on the river to alter the channel. And we also did some work, not here in New Brunswick, but in another study, actually Natalie, my former PhD student, who I borrowed a photograph from her where we actually looked at diet of tree swallows just to kind of tie things together a bit more. So to get on to what I've really been asked to talk about, riverbank erosion, which again, we've heard a lot about already. I'm not going to go over the diagram. Ms. Swan, I think, showed something almost identical in his presentation. Actually, what I'd like to do is to direct you towards this really excellent paper that came out, I think in 2008, by Florsheim et al., looking at, and I just loved it for the title, Bank Erosion as a Desirable Attribute of Rivers. And again, you've heard this multiple times this morning, that we all tend to think of erosion as a negative thing, but in fact, it's a necessary natural process for sustaining river ecosystems. And as we'll see, it's very, very difficult to, it can be very inconvenient for us, like many natural processes. But, it helps, as I've shown here, it helps to create diverse riparian and in-stream habitat. These vegetated riparian edges stabilize banks, but they're also, and this is something that nobody has mentioned so far, they're a very important source of large woody debris, which in rivers form a critical habitat. And again, can be very inconvenient. For example, if you want to encourage kayaking on the Nashwaak, you don't want the lots of trees across the river. But in natural rivers, these large woody debris play a very important resource in creating diverse habitats for various species. Bank erosion also influences stream flow and channel properties, both upstream and downstream of any intervention in the system. But again, the one point, I think this has been alluded to already, the interventions when you try to stabilize eroding banks often have unintended consequences, many of which harm critical river ecosystem goods and services. The important thing to remember is a river is basically, and I'm going to talk a little bit about physics here, it's an energy dissipation system. So in other words, rivers flow downhill, potential energy basically works the landscape to create landforms, to create the river channel. If you put something into that system, you alter the distribution of energy within the river channel. That's why when you have a bridge in a river, you get scour, but you may also get deposition. You basically, the bridge will reflect energy back up the channel, and it will also alter the distribution of energy downstream. And often when you do something like that, it can take years for the system to come into any kind of equilibrium. And I'll return to that issue in a moment. So basically interventions also to remove existing barriers to flow, for example, dams or weirs, will also have consequences, because you're now taking out that system that's altered the energy distribution, and you're changing the system again. And it may not return to the system that you had before. It may find a new equilibrium. I just thought this would be, I saw this, basically this is a study that was done by Bodrick et al. In 2009. They had a 17-meter flume that they filled with plastic beads and stabilized with alfalfa. And they created a channel in it, and it basically, they simulated the process of how river meanders form. And I thought it's kind of cool because you can actually watch a river being created. So obviously that's the thing that they move up and down the flume to take measurements and stuff. You're wondering what it is. So you can see there meanders starting to occur, and then you may get breakthrough channels. And this is basically how rivers in a natural state, how they develop over time. It's not like you have a river and that it's like that forever, right? It's a constant erosion, changing of landforms, redistribution of energy, and sometimes the channel will just move to a completely different place if you have a major event, like a more, well, let's not get into that yet, but the 100, 200-year storm thing. Anyway, I think that's gone on for long enough. So anyway, let's look at natural and human causes of bank erosion. So we can have seasonal and storm-driven floods, including ice scour. This is a photograph I took of this is Wollastock in 2018, where we had a pretty decent flood. I just wanted to show this picture because it gives you an idea of the sheer amount of sediment that's being transported in the river. I took this photograph really early in the morning, so we had that, was it called golden hour? Really, because often you can't really see that very well. But you can imagine in the Nashwaak, when it's in flood, it'll be the same thing. You get large amounts of material transported. It's not constant throughout the year. When you get big flood events, things start to move around. Ice scour, this is a photograph I took in 2018 on the Nashwaak, actually not far from the earlier photos on Maysville Flats, just to show you the amount of damage that the ice scour can cause. This completely wiped out the cycle trail. So I came with my bicycle and it was like, I'm not going anywhere. You can't really cycle through that very easily. So, but you know, where that ice is moved again by floods, obviously it does a lot of physical damage to the river, both to the banks and to the bed. And that'll vary a lot from year to year. Although, as some people have alluded, you know, maybe ice jams are going to be, you know, less frequent if in a warming climate as things change. Secondly, ecosystem engineers, and by that I mean our friend the beaver, right? I mean, everybody loves beavers, of course, lots of people hate them. I have research colleagues who loathe them. I'm a big fan of the beaver myself. Also, so beavers are kind of natural engineer, alters the river channel, creates habitat, but we also have livestock, which can be a big issue, you know, entering the river channel if the river banks are not fenced. So that's a kind of ecosystem engineering, but maybe not the kind that we like, although it may obviously be of value to the landowner if there's a drought and their animals want to get water, right? So that was the best picture I could get locally of a beaver pond that I had in my photo library. So, and I stole the cartoon beaver from Brian Gable from Globe and Mail, so he can sue me, I guess. In-channel infrastructure, dams, weirs, bridges, piers also cause bank erosion. And a very good example that locally is the Maysville, the dam that was removed to restore the fish passageway in the Nashwaak, the Campbell Creek Dam. This is what it looked like beforehand, and this is what it looked like afterwards. I think it's a bit, it says, despite good intentions, Fredericton Man says creek restoration was a mess. The thing is, when you take a dam out, it doesn't suddenly stabilize and become normal. The channel's going to take a while to recover. It may take years, and there may be continual change going on in the banks downstream, because you've caused a major redistribution of energy within that system. And the energy does work, and the work causes change. Alteration of riparian edge, we've heard a lot about that, a lot of stuff about tree planting in the floodplain, which is awesome. And the issue of tree removal, people who live by the river think, they've got all these trees in front of my property. If only I took those away, I'd have a beautiful view of the river. And then suddenly the river starts to get closer to their house and they wonder why. I was looking again for some photographs. We've been working in a system on the Ottawa River over the last few years, just to show you, this is very much a non-natural river. It's kind of a ditch, basically, in an agricultural system. But you can see a vegetated riparian zone, and then farmers managing the system in order to, because basically the issue here is these are tile drains. You want to get water off the field, so you don't want all these vegetation clogging up the ability to get water quickly off the field. So the farmers there dredge the channel, remove all the riparian vegetation. Now that's obviously a very extreme example, but as soon as you do that, then you're going to get erosion of the system. You're going to get more sediment transport. You'll get material coming out of the banks going into the river, causing sedimentation and ultimately silting up of the channel. Then you need to dredge the thing again. The other thing is creation of channel bank stabilization structures, and Mark had a good example in his presentation with people using, I think, part of the road I got a nice series of photographs. I particularly liked the one in A, which was a very creative use of, I wonder if these are Teslas actually, but you know, these are different methods of bank stabilization. You've got things like, you can use old cars as people do locally. You've got things like riprap. You have this, I think they call it sandcrete, where you have like sandbags that are made of concrete and a bit of riprap. And then there's the other things that I've forgotten the name of in the other diagram. But basically, all of these things will stabilize the banks, but they all have unintended consequences for natural habitats. Either, I mean, as Juan said earlier, you know, if you put this sort of thing in, bank swallows are not going to be going with, you know, with their Swiss Army knife to cut a hole in the sandcrete to kind of dig a burrow. That habitat's gone. Also, because the work that was being done and the energy that was dissipated on this system is no longer happening, it gets transmitted further downstream. So basically, downstream of these structures, there'll be more energy available to cause erosion downstream. So it's a bit like you're passing the problem on to somebody else. So I just wanted to kind of finish off by talking a little about the implications of future climate for riparian bank erosion, and just for erosion and river channel and floodplain habitat in general. When I moved to Fredericton in 2003, I thought living by the river would be a great idea. So I bought a house, and this is the street that I was living in 2008. Luckily, our house did not get majorly flooded, but some of my neighbours were completely washed out. We had people kayaking up and down the street and getting their photographs taken. People don't like it when you do that. But so in terms of future climate, there are two issues we're looking at here. One of them is spring floods, when all the snow melts in the main North Woods and comes down the river. How quickly does it happen? Does it happen when there's a lot of rain associated with it? When this flood happened in 2008, as you can see, it wasn't raining. This was just a huge amount of melt going on upstream. The flood peak just basically propagated downstream and flooded out downtown Fredericton. So this sort of thing is fairly predictable. We have river watch. We know when the flood's coming. We know what to watch out for ice jams, for exceeding the flood stage. People can get plenty of warning. What's more of a challenge from a climate point of view are these extreme events. And these are two examples. The first one was the insane amount of rain that fell in St. Stephen in 2010, I guess it was 2010, and you know, washed again the downtown underwater. A similar thing, you know, happening in different parts of the world. You know, these extreme events are the kind of thing that completely change a river channel. So no matter, you know, you may even have bank stabilization structures in the system. You may have all kinds of things to manage the channel. Something like this comes through, it's very difficult to plan for it because it's often an out of concept problem. Basically, out of context problem. That's the term. And that we don't have anything to come. The events, these things are unprecedented. We haven't seen anything like this before. So the question is, why is this a problem now with climate? And one of the things I got interested in, there's a couple of papers published recently. This one here looks at, obviously now I'm moving from kind of the Nashwaak to the planet as a whole. But I think this has lessons, I think, for us. That basically, if we look at the water cycle, the hydrological cycle, we know that water basically is conserved on the planet. But it obviously goes from, you know, snow melts, it runs down the river, it can evaporate, forms clouds, it could go into the ocean. you know, it comes back and rains down, you know, and there's a cycle that goes on. But, you know, the cycle now is being altered by the amount of moisture present in the atmosphere. And so climate scientists have pointed out that there's more moisture in the atmosphere now than there has been for a very long time. And part of the reason, as you can see here in terms of minimum, this basically looks at the year of minimum freshwater storage. In other words, this is periods where this is the least amount of water on the land that there has been, and it's all fairly recent. So you can see, you know, all that water is gone. Well, where's it gone? It's gone into the atmosphere or into the oceans. Now, if you look, I mean, if you probably looked at New Brunswick, you say, well, it didn't look too bad there, but just to remind you, this is a drought map of conditions. This is from last month, sorry, from January 31st rather. And you can see that part of the province here is abnormally dry. Another part of it in the south is moderately drought. But, you know, we are pretty dry at the moment. Now, one of the things, this other paper that I've said, there were two papers. This second one, I think, is a message for everyone in the sense that basically these guys looked at the ability of current climate models to predict extreme events. So in other words, where extreme events are occurring, are they outside the limits of what's predicted by current, the best ensemble IPCC climate models? And basically what that thing on the axis on the right-hand side there looks at where you're getting kind of out of prediction systems. So you can see pretty much everywhere we're now getting events that are outside the level of prediction from the models. So it's kind of, you know, if you look at New Brunswick, you know, there doesn't seem to have been much going on here, but in other parts of the world, I mean, these may be thermal events, they could be rainstorms. There's a lot of unpredictability. And that's really the big message with climate. You know, in terms of planning for it, we have to plan. There are some things that will be incremental, but many of these things will be very unpredictable. Other than that we know that these things can occur, but we don't know the probability. This is from Tropical Storm Helene last year in North Carolina, just to show, we talk about bank erosion. Basically, this massive amount of rain that was deposited by Tropical Storm Helene just completely wiped out infrastructure in the Carolinas. I don't know if any of you have seen the drone footage going down the river channels. It's really quite astonishing how much damage. Basically, this was the highway completely wiped out by a major storm event. So key points I wanted to make on climate, just to kind of finish off, is that in addition to risks from seasonal flooding, extreme rainfall events have the potential to cause major changes in channel structure. So in other words, you may see, before and after the storm, the river may look quite different. And this can include obviously sudden collapse of eroding banks, particularly those that are not stabilized. Extreme rainfall events are becoming more frequent and more intense because of increasing atmospheric moisture content. And dieback of riparian forest can exacerbate this, as local species, tree species succumb to temperature and drought extremes. So again, being able to hang on to your local species is really important, as we heard from the guy talking about bur oak, but this is going to be a big challenge for us all in the future, for future generations. It's important to conserve storage capacity offered by riparian wetlands because, and this can include things like beaver dams, is it can increase system resilience by reducing flashiness. In other words, when you get a major storm event, these beaver pond areas, the catch basins can store water, reduce the rate at which it moves through the system. it dissipates some of the energy rather than having major effects on the main channel of the river. So once you start to remove these things from the system, that's when you see major impacts. So the nice thing about rivers around here, as David alluded to, I'm also from Europe. So when I came here, I was going like, wow, this is kind of pristine. Like he said, it's like pristine compared to what we have back home. But we still have many of these things in our rivers here, and they need to be protected for that reason, in as much as we can, obviously within social license to operate and so on. So promoting diverse natural riparian habitats is key to climate adaptation and mitigation of bank erosion. That's, I think, the big message on climate. So that's pretty much all I've got. I don't have any conclusions, only questions. So I just acknowledge for the work I mentioned earlier, Tamarazi's work funded through NSERC. A shout out to my PhD students, including Natalie, who's sitting over there, and some field support we had for that project prior to me retiring last year. So thank you very much.
We have time for a question or two, if anybody has any. Going once, going twice. All right, thank you very much, Donald. All right, before we jump into our panel, we are going to do a quick prize draw for some Nashwaak swag. And we've also drawn 3 random people from our online attendees today. And so I'll say their names first, and we'll contact you and make sure we have your email, and then we'll send out some things to you on Monday. So from online, we have whoever is attending from Nature New Brunswick. Congratulations. We have Michael Pelletier and Kate Dreyer. So thank you very much for attending online. All right, and we're going to do a few different draws, so get out your little yellow tickets if you're in person. And Jordan, one of our summer staff, is helping us out today. Okay. Ooh, too many. Okay, last 4 digits, 5538. Woo, Shaylin, hey. All right, you can pick between a hat or a buff, so whichever you'd like. It's not rigged, she's on our board, I swear. Last 4 digits, 5542. Hey, Mary. Okay, 5498. All right. One of our upcoming summer staff. Grayson. 5499. Oh, Lauren. Just sit down, and he's making you take it. Yeah. That's all right. We'll do 2 more. 5497. Perfect. Hi, Natalie. Awesome. You can pick hat or buff. Hat. Natalie was the next one over there in the red. And the last one, 5500. Ooh, awesome. All right. And it was Logan? Lucas. Darn. Okay. That's it. That's all. Put them back in. Thanks very much. You can pick between a hat or a buff as well. We'll get all of our panelists to come up to the front here and prep for some questions. If anyone from the audience has a question, I can be a floater with a mic, but there's also the lovely green one set up in the middle. So let's go with the one that's standing. Okay. Okay, so Tanya's going to lead us through this this panel. You can get out your questions that you've been saving all day and feel free to ask them. And Tanya will also be handling some questions online as well. We'll give the tech guys a minute to adjust cameras. Okay.
Okay, hi everyone. So we're exactly on time, which is really nice. I'm going to start with an online question, and I was really hoping with a group this size there wouldn't be crickets, so if you've had any questions about erosion, please don't be afraid to ask. This is a great panel of experts. I'm going to start with one that was, I believe, directed for Mark Pulsifer. It's from Mike Rushton online. It says, examples of in-stream structures that can collect waterborne sediments to improve fish habitat, but simultaneously create or retain significant sandy habitat for turtle nesting grounds, for instance. So that's a big one. Do you know of any structures that might do this?
Yeah, hopefully, yeah, okay. Yeah, it's interesting. Just take a step back in terms of wood turtle nesting opportunities. So they typically nest on bends or turns and watercourses, and it's sand and gravel, so it's fairly well sorted material. So how to retain sediment within a watercourse and yet still build gravel bars for turtles to nest in. It's difficult. You might be able to do something with deflectors that will gently scour and then deposit sediments downstream on the next turn, or the problem with that is, as has been alluded to this afternoon a couple of times, is you start creating problems on other properties. And again, theoretically, I suppose you can nudge a watercourse a little bit to do something. But the implications in terms of land ownership can be something that you really don't want to get into. You end up getting sued, but that's not the question per se. So can you do something? I'd probably suggest it's something to do with deflectors, but you have to be very careful with how you do it.
Great, thank you. Okay. There's no one rushing to the microphone. Oh, yay. Okay, thank you, Robert.
Question for Donnie, not about erosion, but more about the oaks. I think you mentioned briefly that there were white oaks at one time. Did I hear that correctly, or just white oaks, the group?
Yeah, so just the only white oak native to this part is bur oak.
Okay.
So in all of the old literature, if you saw white oak, then you could infer that it had to be bur oak.
Gotcha, thank you.
Hi, Annie.
Cool. Hi. Thanks, presenters. All of your presentations were great and very informative, so thank you. I was just curious from the deflector question online, and Mark, you touched on, have any of you heard of post-assisted log structures or PALs? I know they use them a lot more out west to kind of reintroduce woody debris and to help make more of a meandering stream, and I wonder if that would be a solution for any of those problems.
Yes.
Cool.
No, I think that any time that you use natural materials to again, I used the term gently nudge before, that you can use those type of materials to slightly move the downstream morphology of the watercourse, that you increase the potential, I guess, for depositing sediments where you need to, for what purpose you need them for. And of course, woody material, which is a great one which is mentioned, Donald mentioned it, and it wasn't something that I talked about in this particular one, but those are, yeah, potentially good ways in which you can do you're suggesting. I hadn't heard of it personally, so.
Okay,
but
that was
thank you.
another thing too, if any of you have worked with those structures before, because I know they're very prevalent on the West Coast, but in the East Coast, they haven't really been utilized. I was just curious, but.
Yeah, certainly not for me.
Yeah, they're being used quite a lot in Europe in the alpine environments like Austria, Italy, Switzerland, Germany. That's where they are. German expression for it's Graubäume. There's literally you can have different effects simply by the type of tree that you're selecting for it. And for example, like, and if you just use the log, if you keep the branches on it, again, in terms of microhabitat, like needle trees, like evergreens, or hardwoods that will shed the leaves immediately, also like the local pH environment that directly within the structure that can be created. So, yeah, they use it, in areas with high gradients often to have a natural deflector, yeah.
Cool, awesome, thank you.
Thank you.
Thank you for your presentations. So if we're considering human-caused sedimentation by the removal of vegetation, so if there's a lot of vegetation removed and we want to kind of prioritize where we want to revegetate those areas, what would be the best predictor of too much sedimentation? Is it slope? Is it something else? Is it best to work upriver, considering all the downstream effects? Anybody?
I think a lot of it's got to do with what scale you're managing the system at. If you're managing at the watershed scale, then obviously you'd be thinking about, optimization of where to put things, and then that would obviously begin to collide with reality of where people will let you do that, whether it's feasible to do that. But again, it's locally it's wherever you can find a place to do it, that it's going to be sustained over time. So, and that's the big issue with any intervention. Generally requires more work. It's not a one and done thing. And the point I was making with climate change, many things that were one and done in the past are now coming undone. And that's something we need to think about as well.
Yeah, I think something else to note on that is erosion's still not really well studied. So the cause and effects aren't well studied either. Everything's hypothetical and referencing outdated literature that aren't in situ. So we're looking at building an erosion model, which as far as I know, does not exist yet for the Nashwaak at a watershed level scale. But like Donald said, I think it'll be looking at managing watersheds and even understanding erosion and what it looks like in real life and how it can affect downstream habitat. Do you have some on? Oh, yeah.
I might have one addition that I guess often gets overlooked. We didn't necessarily address it also in river vegetation, macrophytes, and the effects. And again, depending on what kind of, you're in a riverine system or in a lake. But I guess a topic here that is very popular right here in the Woolstock Eurasian waterfall that actually has the capacity to grow throughout the entire water column. And then, so if you have that increased sedimentation, still the capacity to get the light to produce the photosynthesis and then out competing other macrophytes that are not growing that high in the water column, but they also would have their function in the system to stabilizing in-stream sediments. So that increased sediment input can, not just on the terrestrial side or what gets seasonally flooded or not, but often gets overlooked, the effect on the macrophytes in the water as well.
I just want to add something else, and just when we are considering the idea about this erosion model, and I think like one of the limitations we have here is the lack of information on the river's structure, like morphology, depth, that are necessary to build like flow models, and also we lack information, a finer scale about soil granulometry, type, and which are factors that will affect how fast they are eroding as well. So in addition, like we have factors that we might know, but that we can know, but we don't know right now. And there are factors that are quite random. So everything it's modeled within hypothetical situations, right? But it's just an estimation. Yeah.
Hi.
Hi, David.
Not so much as a question as an anecdote that perhaps illustrates a little bit the rate at which some of these changes come about on our river systems on account of erosion. And I don't know, this is maybe a little question for you to think about, you know, casting back up and down the rivers 100 years ago, 200 years ago, we were having log drives, we were building railroads, we were building roads. A lot of these things were major disturbances without a lot of consideration given to the effect on rivers. So I'm kind of speculating that maybe there was a lot more erosion maybe 100 years ago than there is today. Kind of be interested in your comments on that. While you're thinking about that, 20 years ago or so, in 2001, there was a gentleman by the name of Bert Glendenning who was the provincial archivist. And after he retired, he went through photos at the archives and produced a book called Fredericton Then and Now. And so it consisted of photos from about 1900, 1901. And he went back to the same spots as best as he could 100 years later and took another photo. And there was one dramatic one which was taken from the slope over by the university, looking across towards Devon and the mouth of the Nashwaak River. And I looked at the 1901 one and then looked at the 2001 one, and then there's something really different about that. And in those, realized that in those 100 years, an island had formed at the mouth of the Nashwaak, where there wasn't even visibly a sandbar in the 1900 photo. And that island is, when you cross the Nashwaak on quote unquote the new bridge, that bridge was built right on that island. So it's just kind of, you were talking about the time frame for these things to happen. It's relatively short in the great scheme of things.
Thank you, David. Anyone?
Thank you. When you were mentioning, I guess, basically log drives, I went back to the St. Mary's River system in Antigonish, which is just a half an hour south of me, and thinking about that particular river system, which it's a large watershed. It's probably about 1,600 square kilometer watershed, and one of the branches that is about 60 kilometers long. And I was thinking about, there used to be historic log drives on that river, which widened the river from what should have been around 40 meters wide to upwards of 150 meters wide. So to your point, I guess, basically, that the capacity for the system to absorb that kind of dynamic change is really difficult, and to know what it's done. And certainly that's particularly the reason why the local Salmon Association has been spending, you know, a few $1 million trying to restore that and take it back to the width that it was. So I'll make that point. So I'll agree with you at that point that certainly the capacity, I guess, the ability of these historic log drives to increase erosion, and subsequently what happened there is it took so much of the bed load out, so it went right down to bedrock. Basically, there was, with partly the log drives were doing that, so there was a tremendous loss of in situ sediments, basically, which are still having profound impacts on the local ecology. And there's been a lot of work done in the past 20 years to bring some of that back. But I would also, in addition to that, say that I would question a little bit about it being the #1 driver of erosion. today. I'm thinking that the combined effects of a lot of our land use practices at the watershed level would probably scare you in terms of the amount of cubic meters of sediment a year that are ending up in watercourses as a result of the combined activities of everything else that we do as a society. That it might make some of those historic things pale in comparison. Just my thoughts.
I just also want to make the point, I mean, again, I've seen photographs of log drives and it's kind of astonishing the amount of damage that those things must cause. But then the systems clearly are fairly resilient because they have recovered to a certain extent. And then, of course, you need to remember that the ice processes have very similar impacts on the morphology of the channel. So kind of a log drive is kind of like an ice, like the ice breakup, but at the wrong time of year. So one advantage you might say here compared to maybe more southern systems is that systems were relatively pre-adapted to that sort of extreme damage. But I mean, obviously, you know, the scale of it can still be quite staggering compared to even the worst ice jam. But these major, really quite damaging events will happen quite frequently in large rivers, right? In northern habitats. So.
I guess in that regard, there's also leftovers from all that log drive. I think if you were on the Miramichi River and you were specifically on the southwest Millerton and up, there is still these in-stream structures that they had to guide the logs. And they still have their effects today. Those were built bulletproof, and the same thing on the northwest Miramichi, Red Bank area, where you see all those, wherever they built them. It's impressive what the people were able to build in like hundreds of years ago. They're still there, and they're still having an effect, artificially directing water flow and energy into areas where it would not naturally be up to today.
One.
I just have a thought, and I want to bring it to the table, just maybe related. I was just thinking about maybe the changes on the type of particles that are being eroded at the river. So maybe the proportion of coarse versus fine sediments has changed as well over time. So maybe in the past, there could have been more sedimentation of coarse sediments compared to today, that we might have more finer sediments. And that's why we don't see like many deposits, but these sediments just run away, right? So yeah, maybe it's related, I don't know. I don't know that much about the system, but it's a thought that I have.
Okay, thank you. We do have a couple online that I'd like to get out. Someone's been waiting since Donnie's presentation. So Donnie, this is John Rice, or Rice. If I plant my bur oak on my land, how long before it starts to produce acorns? Same goes for red oak. And then just to follow up, I think these could go together. Where can you get bur oak seed? Which I know we've been talking about, so.
Yeah, so the plantations that we put in back in 2000, a lot of them on the floodplain within 10 years, they were actually reproductive, which again, the literature says something 40 to 300 years where they're reproductive, but we've noticed definitely, and again, anyone in town, if you walk on the trails along the St. John River, you'll see little bur oak, and a lot of those, if you like in front of Picaroons, there's a couple of trees we planted 20 years ago. Over by Ducks Unlimited, there's a couple of trees we planted 20 years ago. My backyard, I have 3 trees, so it's really encouraging to see bur oak coming up along the trail systems. Just kind of cool. Yeah, so bur oak acorns, as I said, our bur oak here only produce acorns every 3 to 5 years, depending. Again, a lot has to happen to get a good bumper crop. And then they only last. So anything you collect in the fall, you really have to plant the next spring. But the National Tree Seed Center has been working on Gary oak, which is a West Coast species that's under threat. And we found with Gary oak acorns that we can actually store them at -1 degrees constant and actually get 2 to 3 years out of them. And then the other is we're doing a lot of work with cryogenics. So again, the Bort group, one of our big goals the next year, there's a bumper crop acorn years to collect as many as we can. And the National Tree Seed Center will help store those so that we'll have local seed for years.
Great, thank you. There are more online if no one wants to jump up. Okay, great. Donald, this is about your bird box that a tree swallows on. Someone wants to know, what about bluebirds? Yes.
I have no idea. Basically, of 25 bird boxes we put up, I think only 3 of them had nests in them, and they were all tree swallows.
Okay, okay.
So no bluebirds.
Okay. And then from Mike Rushton, they want to know, understanding that expert geomorphological surveys are best, what are some common criteria or thresholds for determining when erosion is fine or needs remediation? So this one I can touch on because this is usually what we're dealing with our natural edge program and floodplain restoration. We're currently working on a project with Hillcon. Basically, if you're not protecting infrastructure, you can probably leave it. It's natural. The stream is moving, you don't need to change it. If you are protecting infrastructure is when you could look at remediation, but I think online literature says 0.5 to 1 meter a year could be alarming rates, and this is usually due to lack of vegetation on the stream. So you could just start with some less invasive techniques such as planting farther back onto the bank, and that's a great method. In 20 years, it's going to hold the bank in place. If the river decides it wants to move, it's going to take those trees with it. So I think that's a better I hope that answered your question. If anyone else wants to touch on that, okay.
So there are also exceedances that you can find online through CCME, and that just talks about how much of something can be in the water for the protection of aquatic life. So that's something else you can look at. Like there is a CCME limit for total dissolved solids in water. And if those levels, when you're testing water quality, are all looking concerning for the protection of aquatic life, that could be worth looking into remediation, because at that point, the level of erosion is not good for aquatic organisms.
Okay. So again, I guess everything's adaptive in this world, always looking at species at risk and those specialist species that need that habitat. Does anyone else want to speak on that? Okay, there's one more question and then we can open up for a couple more on the floor. But John wants to know, I have beavers on my property and they said I have made a low dam that is spilling over, causing erosion. Is there something that I can plant downstream of the dam that would collect sediments? Probably vegetation. I don't know, anyone? Ben? Yeah. So I don't know on this one. Beaver dams you're not legally allowed to touch, right? So further downstream, I'm not sure what you could use to collect sediments and deposit, but I think just letting nature take its course is probably okay. Planting some trees is probably never going to hurt either. Nature is very good.
They're not just wood, they're wood and mud, very solid. If they're there for a certain period of time, you're not allowed to.
Yeah. I'm going. Okay, oh, you're gonna go over? Okay.
No, I had personal experience with beaver, and it's nice for a while. You can go out and see them working, and it's kind of, anyway. They actually built a dam that was probably 60 feet wide, and it took this little brook, so I used to fish in when I was a kid, to be like 6 to 8 feet wide, and it flooded a whole field that we used to cut hay from. And So they got to be more than a nuisance. And the main road going from that point back to my woodlot was removed. Couldn't get there. And you couldn't get there for fire or you know, like people from, it's a managed woodlot, so, you know, you're working with a forestry technician and so on. Anyway, so I checked on this and you can't do anything about it. But some people take it matters in their own hands and deal with them, but I didn't wish to do that. So fortunately for me, a year or two later, I go out and there had been a lot of water in this brook and it just folded about 30 feet of that dam around. The water went out, it's still out, thank goodness. Nature. If you work with nature, you'll win every time. If you buck nature, you lose most of the time.
Well, I appreciate your case study, Dalton. Allison has one question. And that, no, local examples are the best. That's what really helps us in our work. So Allison has one more question, and then we're going to finish up. It's Friday at 4 p.m. If anyone has any questions, we're going to share all of the emails. This will be posted online, and you can reach out to any of these experts. So Allison, finish us off.
All right. Okay. 2 quick ones. The first one I'll ask and then give you a second to think, and then I'll propose the other. If you could ideally have industry or residents take one like tidbit of information and keep it in their brain, what would it be in regards to sediments? And then just as another one, is the concern about sanding the roads within city limits and over the highways, is that a big concern to sedimentation in the rivers? And if so, has there been case studies about trying to make managed wetlands where you dump all the snow from plowing and then have sediment collected naturally that way? Just 2 quick questions.
I'm going to start this a little bit, Ali, with your first question. Basically, I would just say that take-home message, as I said earlier today, is erosion's natural. Work with nature when you can. Don't get too twisted up too quickly when you see some erosion. Obviously, you want to protect infrastructure where you can. And if that's the case, then look for options that are going to allow you to basically be able to protect what you want, but also don't be doing something too detrimental downstream from that, so to speak, ecologically. So I'll say that.
I guess when you touch on roads, the number one problem is the temperatures from tires, the microplastic source. That is really doesn't belong into the system, one of the major sources worldwide. So catching that before it enters any of our aquatic systems, and everything else that's going to come from the roads would get caught as well.
Okay, I think that's it. So everyone online is saying, Willie won, thank you. They learned a lot. I hope you all learned a lot. I kind of picked everything I liked and was hoping other people would learn some things. I do work with erosion every day. And these are a lot of the questions that I still had. And a lot of the answers are not found online. Okay, what? Yes. If you could leave your name, these plastic name tags, you can take these with you if you're a collector. I don't know if some people do that, but we just reuse them because this is our first time we bought them, and we just would like to keep them. Yeah. No, thank you. No, you can take the folders. They're good quality folders. Yeah. Yes, and presenters, actually, if you could have a seat, you don't have to stick around. We're going to give them some gifts, but if you want to, put them on the spot. Sure.
Thanks, everybody. Just a couple quick closing remarks. We sincerely thank everyone for attending today, online and in person. Thank you for our wonderful presenters, David, Mark, Donnie, Donald, and all of our Nashwaak staff. Killarney Lodge, Jenna's Nut-Free Dessertery, Decadence Fine Baked Goods for the gluten-free items, Nat Gauguin from MBEN for facilitating online, Cero Communications for doing the live translations, and our wonderful AV crew. And last but not least, the Nashwaak staff for putting on such a great and informative event. So. And the funders, always the funders. Wilewan, Walalin, merci, and thank you so much for sticking around today. Safe travels, everybody. Please grab snacks for the road.